Hello students, how are you? We have finished the question of type 3. Only I think one or two questions are remaining. So for that one or two questions I will solve it, and that image I will send you on the group. So from there you can see the questions. Now today we are going to solve the questions of type 4. Type 4 is basically, you can see the heading here, integration by trigonometric identities. Means here, while doing the integration of any trigonometric function, we shall use those kind of formulas which we have learnt in the class 11th. Okay, so in class 11th many formulas we have learnt. For example, 2 cos a cos b, 2 sin a sin b, 2 sin a cos b, or cos c plus cos d. So this formula whichever we have done in the trigonometry of class 11, that all formulas will be applicable. So let us see the question number 1 today. First question, as per the assignment, this is question number 1. Okay, so it is given sine square 2x plus 5. So here you can see integration of sine square means integration of any trigonometric ratio square is not possible. Only one or two is defined for the square. For example, integration of sec square we know, or integration of cosec square we know, but integration of sine square, integration of cos square, that we don't know how to find out. So to come out from this problem, we have applied one formula. Sin square theta is equal to 1 minus cos 2 theta upon 2. Actually this formula is a formula of cos 2 theta. Cos 2 theta is equal to 1 minus 2 into sin square theta. Okay, so if we shuffle the terms from that formula and find out the value of sin square theta, it will come like this. In the assignment, if you see this all formulae of this kind already I have given to you. Okay, so from there you can take a reference and see how the formula we have applied here. Now according to the formula here, theta I am getting it, and double of theta is coming, means 2 theta is coming in the place of cos. So here my value of theta is 2x plus 5. So 2 into 2x plus 5 will come, because value of theta I am keeping in the formula. Now 2 will multiply inside, and this 2 in the denominator I am separating with the terms of numerator. So 1 upon 2, that is constant, I kept outside. So first term remain nothing, so I kept here dx, and similarly here also 1 upon 2 will come, because upon 2 will write down with the fraction 1 upon 2, and cos of 4x plus 10 I kept here, because 2 I have multiplied inside. Okay, now remember, any trigonometric ratio, if the angle is a linear polynomial, then definitely we can integrate to them. Okay, any trigonometric ratio, if it is coming under a linear polynomial, you can see 4x plus 10 is a linear, because power of x is here 1. So any ratio you can integrate if its angle is a linear polynomial. How will you integrate? First of all, see the integration of dx. Integration of dx is becoming here x, and integration of cos is equal to sine theta. Remember, integration of cos is sine theta, but in differentiation of cos is minus sine theta. Okay, so here integration of cos is coming with the positive sign, and angle will be coming as it is 4x plus 10. Whichever the angle it is given to you, that angle you can always differentiate. Remember, that angle you can differentiate in the place of denominator. As we apply the chain rule in the differentiation, here also we are applying the similar kind of process. Okay, so 4x plus 10, if I differentiate, derivative of x is 1, and derivative of 10, since only constant is coming, so that will become 0. So this will remain 4, and 4 will multiply to 2, afterwards it will become 1 upon 8, and this will be your final answer. So in this question we have learnt how to integrate of any trigonometric function if a power is given other than 1, like 2 or 3. Now 3 1 we can see as question number 4. Okay, students, I am leaving the question which are similar kind, that I am leaving for you. You are required to try that question, and please give me the feedback whichever the question you are unable to solve. Look at the question number 4 now. As per the assignment, this is question number 4. So it is given that sine cube 2x plus 5. In this question, we have given that sine cube 2x plus 5. Here I applied one formula. Sine cube theta is equal to 3 sine theta minus sine 3 theta whole divided by 4. In place of theta, I have given the angle 2x plus 5. So look at here, 3 sine theta minus sine 3 theta. Same exactly the formula given to us. I wrote the value over there only in place of theta. As per the question, whatever the value given to me, that I have kept here. Upon 4 is coming as it is. Now separate the integration. So 3 upon 4, because 3 is numerator and 4 is denominator. So 3 upon 4 is coming separately here. Integration of sine 2x plus 5 dx. And same way here 4 is coming only. So I wrote 1 upon 4. And 3 is going to multiply with the angle. Remember, this is a complete part of angle. This 3 cannot come outside. Okay, so 3 is a part of the angle. It will multiply with the remaining terms of the angle. So 3, if you multiply inside, this will become sine 6x plus 10. Okay, now let us integrate them. As I told you earlier, if any trigonometric ratio comes with an angle linear polynomial, then directly you can differentiate. Think of what is the integration of sin x. Integration of sin x is minus of cos x. So minus sign is coming, value of angle I kept as it is, and the angle which is linear polynomial I am differentiating at the place of denominator. However, such kind of method you have covered in type 1 also. So you are not aware about it, that is not possible. So 2 into derivative of x is 1 and derivative of 5 is 0. Same way 6x plus 10 I also differentiated in the denominator, and little more simplification is giving you the complete answer. In this question, the answer given in the assignment, that is not wrong, and whatever we have done, that is also not wrong. Actually, we found the answer in two different forms. In the textbook, the answer is given with the greater power of the exponent of cos. Means here in the answer it is coming power 4, power 3 like that. So they have applied a different technique and we have applied a little different technique. I am solving the question on one pattern, and in the textbook they are solving the question by a random methods. Okay, so here I feel that if you follow one particular pattern, then the things will be more clear to you. So I have tried to solve the question by one particular pattern or one particular method only. Okay, so don't worry if the answer is looking different. If you simplify this answer or if you simplify the answer of the book, you will get at the last both the things are same only. Okay, so now this question number 1 and 4 are over. Let us see the next question. Question number 3rd. I have taken 4 first because first and fourth were same. Okay, now let us see the question number 3rd. In the question number 3rd, you observe three different trigonometric ratios are given and we need to integrate them. Now you will say simply we will integrate cos of 2x and differentiation of 2x will be upon 2, cos of 4x, differentiation of integration of cos 4x will write down, and differentiation of 4x we will write down at the end, and same way we can integrate this one also. But remember, it is not possible. We can individually each and everybody we can integrate. You know that in the differentiation also we applied the rule when two separate functions comes in the multiplication. So we applied the formula d by dx of u into v. Do you remember? D by dx of u into v is u into d by dx of v plus v into d by dx of u. Okay, so here also we may require to apply that same rule, but that rule is yet to come. We shall cover in the topic number 6. Okay, so right now we are not going to cover that particular one, but this question, how we can solve it. See, first of all, I am taking these two terms, and in these two terms multiplying by 2, and to make it balance I am dividing by 2. 2 and 2 will be cancelled, we will get the again original term. But if I write down these two terms along with 2, then I am getting these particular terms in the form of 2 cos A cos B, where A will be equal to 2x and B will be equal to 4x. So formula I am applying cos of A plus B plus cos of A minus B. So let us put up the value here. Now, if I put up the value, then this will be cos of A plus B plus cos of A minus B. Now, these two terms are coming in addition and cos 6x is lying outside the bracket. Now, 2 plus 4 will become 6x and cos 6x also I have multiplied inside. So, now I am getting here 2 cos 6x. Okay, plus 2 minus 4 will become actually minus of 2, but you know that cos of minus of theta is equal to cos of theta, so minus sign will eliminate and we will get only 2x, and then cos 6x I multiplied inside. Now once again, whatever the process we have done with these two functions, with these two values of cos, same thing we have to repeat for this one and this one separately. Let us see. Here again I have multiplied by 2 in both the terms, and for making balance I kept 1 upon 2 outside. When this 1 upon 2 separately will multiply in this one and this one, 2 and 2 will be cancelled, and again you will get the original term, right? So now 2 cos A cos B. You can look at the formula here. Same formula I am applying in these two integrations. Okay. So 2 cos A cos B is cos of A plus B plus cos of A minus B. Same way here, cos of A plus B, A plus B plus cos of A minus B. Okay. Now further we can see 6 and 6 will become 12x. Here it will become 0. So cos of 0 I wrote. 2 plus 6 will become 8. 2 minus 6 will become minus 4. But as I told you earlier, cos of minus of theta is equal to cos theta. So minus 4 will become here plus. Now each and every integration I made separate also. So cos of 12x. So integration of cos x will be sin x. So it is coming sin of 12x, and 12x you differentiate. So differentiation of x is 1. So only 12 will remain. Same thing is happening here also. Sorry, here in this question cos of 0 will become 1 and integration of dx will become here x. And same thing is happening in these two integration also. Cos of 8x will become sin of 8x and differentiation of 8x will be 8. Same way sin 4x we are obtained. Okay, so this will be the answer of this question. This question answer is coming same as per the textbook. Only the question number 4 we have done, it is not coming as per the textbook. So the reason I have told you why it is not coming same. Okay, so now let us see the next question. Sin cube x and cos cube x. Okay, student, this question also answer is not coming as per the textbook, but as I told you, whatever the answer we are getting at the end, the answer if you simplify this one or the answer of the textbook, whichever possible, if you simplify you will get the answer of the textbook as well. So in the examination also, don't worry, the one integration can have two separate answer also. This will happen mainly in the case of trigonometric function, because you know that the trigonometric function we can simplify with the help of trigonometric formulas and we can bring them equal. It may not be possible in the algebraic function, because algebraic function will remain same only and it can't be simplified further. So normally it will happen only in the case of trigonometric function. Okay, so in trigonometric function you may see some differences in the answers whatever we are obtained here. So this question answer also it is different. So the answer is written here. Here power is coming 6 and at the bottom my answer is coming different. But if I simplify either this one or the answer I obtained at the bottom, then both will come equal at the end. Okay, so let us see how I have simplified. I told you I did not change the pattern. If you want to obtain this question, then the pattern we have to change and we have to solve the question by the different method. So if you required, I can bring same answer also for you if you required. But remember, whatever the pattern we are following, we are applying the trigonometric identities that may not be applicable particularly to get this answer. Okay, let's see how this question we can solve it. Now sin cube x into cos cube x. Sin cube x into cos cube x. What I am doing here, 8 I am multiplying and 8 I am dividing. You will say earlier you were multiplying by 2 and dividing by 2. So the reason behind that, this 3 terms, because 8 is a cube of 2. So I am writing these 3 terms as a whole cube. So see, 2 cube will become 8. That's why 8 by 8 I have multiplied and divided. Now you know that the formula 2 sin theta into cos theta is equal to sin 2 theta. So this one same as I wrote sin 2x, and this will become sin cube 2x, because this cube you keep it on side or you keep the whole power, it is same only. Now further I have applied the formula sin cube theta. See, sin cube theta formula is written in front of you now. Okay, only in place of theta I am putting the value of theta as 2x. Okay, so 3 sine 2x minus sine 3 into 2x. Now simplified, this 4 will multiply to 8. Okay, and 3 also multiply to 1 upon 32. For this particular integration, it will become 3 upon 32 and integration of sine 2x. Similarly, this 1 upon 32 will multiply in this integration. So 1 upon 32 will be lying outside and this will be integration of sine 6x dx. Now you know that a separate integration can be easily simplified. Integration of sin x is always minus of cos x, and since it is a linear polynomial, so a differentiation of 2x can be 2 only. Similarly, differentiation of 6x can be 6 only. Sorry, differentiation of 6x can be 6, right? Okay, and then 6 and 32 I have multiplied, 2 and 32 became multiplied, and then finally I got this answer. This answer, I know it is not same as per given textbook, but if you simplify both the things, then definitely you will get the answer same. You will get both the things are equal. You may require to solve this answer or you may require to solve the answer given in the textbook. Okay, but don't worry, it could be simplified any one of them and we can make them equal. Let's see the next question now. Question number 8. Question number 8 is a very simple question. It can come for 1 to 2 mark in the examination. See, 1 minus cos x. 1 minus cos x, we have formula 1 minus cos theta is equal to 2 sin square theta by 2. You have applied this formula many times in class 11 as well. Okay, and 1 plus cos x will be equal to 2 cos square theta by 2. My theta is here x, so it will come x by 2. So I applied the formula, 2 and 2 cancel. Sine upon cos will become 10 because powers are same. So we can write down the value of sine upon cos. Now again the problem comes same only here. We cannot integrate 10 square, but 10 square if I convert into sec square. We are applying here one identity of class 10. 10 square theta is equal to sec square theta minus 1. Sec square theta minus 1. So that formula I applied, then I separate them. Okay, so sec square theta is always equal to tan theta. So sec square theta I wrote as tan theta, and if I differentiate x by 2, okay, so differentiation of x is 1 and upon 2 will be as it is. Integration of dx is coming x. So now we got the final answer because 1 upon 2 will come at the place of numerator. It will become 2 and this is my final answer of the question. Let's see the next one. Now next one is also very simple question, but you need to be careful while applying the formulas. Okay, see, formulas of trigonometry you need to learn very well. That formulas are only basically applicable to simplify the given function. We are simplifying the function with the help of trigonometric formulas and we are bringing the function in such a form where integration is possible for them. Okay, for example cos x. Now cos x you will say which formula is applicable, but cos of 2 theta formula is cos square theta minus sin square theta. Okay, so this formula how we can apply. See here, suppose 2 is not coming, so you observe 2 theta, then here theta is coming, means half of that is coming. So suppose here 2 is not there, only theta is there, so half of theta will be here, theta by 2 will come. Exactly same thing is happening here. Cos x will be equal to cos square, half of the x is x by 2 minus sin square x by 2. And here 1 plus cos x, same formula I am applying as I applied in the previous question. So 1 plus cos theta is equal to 2 cos square theta by 2. Okay, so here I applied 2 cos square x by 2. Now separate the numerator terms along with the denominator. So numerator first term upon denominator, this 2 I kept outside. Similarly numerator second term upon denominator and again 2 I have kept outside. Okay, so here what will happen? These two terms are same, they will be cancelled, only integration of dx will remain. And sine upon cos will come again tan square. And I think you did not forget the integration of tan square is not possible. So integration of tan square I wrote as sec square theta minus 1, identity of class 10th. Okay, then again these two terms I separate their integration along with the minus sign, minus 1 by 2. So minus 1 by 2 integration of sec square x by 2 dx, and minus minus plus 1 by 2, and this is 1 only, so integration of dx only coming. Okay, now integration of dx will become here x also, and here also it will become x. Okay, integration of sec square theta will be equal to tan theta, and differentiation of x by 2, as we did in the previous question, it will become 1 by 2, because differentiation of x is 1 and upon 2 will be as it is. Okay, so now this up 1 upon 2 will go up, will become 2 upon 1, and this one x upon 2 and x upon 2, I wrote together x upon 2 and x upon 2 will become here x. Okay, so x minus 10x by 2 plus c. This is the answer of our question. Okay, let us see the next question now. Question number 11. Question number 11. See, power of cos is given 4. We know that if the power of cos is given 2, we have the formula. See, cos square theta is equal to 1 plus cos 2 theta upon 2. If the power of cos is 3, then also we have the formula. It is also applicable. Okay, but if the power of cos is given 4, then which formula we can apply? We do not have the formula. So here I wrote the 2 cos in the power 2 because bases will be same. So 2 and 2 will become 4. Or you can say I split the power into 2 and 2. So cos square 2x whole power 2, 2 and 2 will multiply, it will become 4. Okay, so here I am considering this particular part. However, this can be also taken. Okay, so cos square 2x whole power 2, I wrote this one as cos of 4 2x. Now cos square 2x formula I am applying, because I know that a formula of cos square theta, that is 1 plus cos 2 theta upon 2. My theta will be here 2x. Okay, so see, in place of theta I kept 2x. 2 and 2x multiplied will become here 4x. Now the problem doesn't solve. We need to open the bracket by the formula a plus b whole power 2. So a square is 1, b square is cos square 4x, because power of cos will become 2, and 2ab, so 2 into 1 into cos 4x, so that is coming cos 4x, and this upon 4 now I wrote as a fraction outside. Now again separate the three different integrations. So integration of dx is coming here, right? This will be cos square 4x is coming, and then 2 into the bracket, 2 into the integration cos of 4x is coming. Now integration of dx we can find out, integration of cos 4x we can find out, but again here power 2 is coming. So student, here again you have to apply the same formula I applied in the beginning. Cos square theta is equal to 1 plus cos 2 theta upon 2. So see, same formula I applied here. Now value of theta only change. Earlier it was 2x, now it is becoming 4x. Okay, and again I am separating them, because here 1 by 2 is coming separately. So integration of dx is remaining from the first term, and here it is remaining cos of 8x. So 1 upon 2 is coming because 2 is the denominator, and integration of cos of 8x I wrote here. Okay, so now let us start the process of integration. You are seeing mostly 50 to 75% the part of your solution of any question of this kind, we are required to simplify the given trigonometric function in such a way that we can integrate them. Okay, so now see, integration of dx is equal to x. Again integration of dx is x, but here 1 by 2 is there. Okay, this 1 by 2 is coming as it is. Integration of cos 8x, remember 8x is a linear polynomial, so integration of cos 8x is plus sin 8x, and 8x differentiation is 8. Similarly 2 is coming as it is, and integration of cos 4x will become here sin 4x. Okay, and sin 4x, 4x differentiation is 4. 4 and 2 we have cancelled, and little bit simplification I have done. For example, x upon 2 and x, you can add them. Okay, so if you take the x common, remaining is in the bracket 1 plus 1 by 2, and 1 plus 1 by 2 is equal to 3 by 2. Okay, so simply I have added them. By taking the LCM also you can add, and 4 we are multiplying, sorry, 4 we are multiplying afterwards. Here 2 and 8 we are multiplying. This is becoming 16 and this 2 I kept as it is. Okay, remember this 2 and 4 could not be cancelled because this 2 is the upon of whole sine 4x and this 4 is a part of the angle. So this 2 could not be cancelled. Now 1 upon 4 I have multiplied inside and I got the final answer. Okay, so this is the answer of my question given to us. Let us see the next one. This is our second last question, and after that one more question will do it. Type number 4, I think we required minimum 3 days to complete. So please, one by one you finish all those questions whichever I left for you. I am taking only some sample questions. Okay students, so some of the questions you do it by your own and let me know if any of the question you are unable to solve it. Now, see the function given to us, sin square x upon 1 plus cos x. Okay, here I am not applying the formula of sin square theta that you know, we have the formula of sin square theta also, because if that formula I apply, then the function will become more complicated and it could not be possible to integrate. So I am writing the function in such a way that numerator and denominator should have some common terms and they should cancel. So here you see sin x only I am taking it. Okay, so sin x if I am taking here, so I have the formula sin 2 theta. Sin 2 theta formula is 2 sin theta into cos theta. Okay, so observe here 2 theta is coming, here theta is coming, means half of that is coming. So if I have sin x, so half of that x upon 2 will come. Formula remains same, only the effect will come onto the angle. Whatever the angle given here, half of that will only come. So sin theta is equal to, sorry, sin x is equal to 2 sin x by 2 cos x by 2. Transformation is same, only the value of theta you can say here I am taking x by 2 and 1 plus cos x. Now this formula we have applied many times, so I am writing here 2 cos square x by 2. Now if I square this one, square of 2 and square of these two function, I will get 4 sin square x by 2 cos square x by 2. And now you see what I have told you in the beginning, cos square x by 2 got cancelled, they have common term. If I apply the formula of sin square x now here, then these will not be possible to cancel and function will become more complicated. So remember, always do not be in hurry to apply the formula directly because it can make you in trouble afterwards. So apply the formula smartly, which is really appropriate and applicable. Okay, so cos square x by 2 is cancelled. Remaining is now 2 sin square x by 2. Now it is the time to apply the formula of sin square theta. See, now only sin square theta is remaining. I can apply. So sin square theta is equal to 1 minus cos 2 theta whole divided by 2. So now you see value of theta is here x by 2. So in the formula also x by 2 is coming. This 2 was a part of the angle. So 2 and 2 got cancelled. And then I have separate the integration. Here 2 and 2 will be also cancelled because this 2 in the whole divided by the term. So this 2 and this 2 is multiplying over there would be cancelled. Now if I separate them, 1 is coming, so integration of dx will be there and then cos of x will be there. Integration of cos x, directly you can write down minus of sin x. Minus sign is coming in the question only, integration of cos x is only sin x. Okay, so any confusion student here? I don't think on this question you will have any confusion. Only in the beginning you can attempt any one mistake which I have told you. So while applying the formula, please remember there is only one way. Can we apply the formula in such a way we can cancel some common terms here? If it is possible to cancel common terms and if you have that kind of concept which is applicable after 2 or 3 terms will be always beneficial. Let us see today's last question. Last question, you can mark this question is important. It has come in some of the board examination also. Okay, so this question is C. This question is for 4 marks in the examination. Some of the questions which I explained you today, that questions may be for 1 or 2 mark also as per the length. Now here, see the question is given in the form cos of C minus cos of D. So I will apply the formula cos C minus cos D. Cos C minus cos D, you know that the formula is minus 2 sin C plus D upon 2 sin C minus D upon 2. Same formula I applied down also. Same. Only the value of C is here x and D is here alpha. While here 2x and 2 alpha. So you can see here I just applied the formula cos C minus cos D. Now from here, from the angle, it is complete angle only. So from here 2 I have taken common and that 2 I have cancelled with the denominator 2. So you can see 2 and 2 is cancelled. And here minus of 2 was coming in the formula, that is also cancelled. Here also 2 and 2 cancel. So after simplification, I am getting now sine of x plus alpha, sine of x minus alpha. And the denominator is coming like that. Okay, now once again I applied the formula sine 2 theta is equal to 2 sine theta into cos theta. See here 2 theta is coming, here theta will come, half of that. So observe, this is my value of theta. So half of that means x plus alpha by 2 will come. So sine theta is equal to 2 sine theta by 2 into cos theta by 2. Same formula I applied on this term also. Sin theta is equal to 2 sin theta by 2 into cos theta by 2. Remember here if I am considering theta, then here theta by 2 will come. If here I am considering 2 theta, then half of that means only theta will come. Okay, because again you see if I apply this formula, some common terms will be cancelled here, right? So 2 and 2 multiplied, it will become 4, but 1 2 I am writing outside the integration and 1 2 I am writing in the integration itself, because now I have remained cos x plus alpha by 2 and cos x minus alpha by 2. The both the terms of differentiation has been cancelled. So now which formula we can apply? See, again we can apply the formula of 2 cos, this is my A, into cos, this is my B. So see, formula is applicable here, 2 cos A cos B. Formula I am not writing again and again because these formulas are from class 11 and you should know how these formulas are applicable. Please learn all the formulas if you didn't do it well earlier. Okay, so 2 cos A into cos B. So 2 cos A cos B is equal to cos of A plus B plus cos of A minus B. A minus B and then A plus B. Okay, so now let us take the LCM. When you take the LCM, here alpha and alpha will be cancelled, and when you take the LCM here, minus sign will multiply in these two terms. Okay, so x will become negative and alpha will become positive. So here x and x will be cancelled. Here it will become 2x and 2 will be cancelled, so remaining is only x. And same way here alpha plus alpha will become 2 alpha, so again 2 and this 2 will be cancelled, remaining is only cos alpha. Cos alpha is constant, so I am keeping outside the integration. Remember it is constant because it does not contain the variable, while this cos x I am keeping as it is. Okay, now integration of cos x will become sin x. Okay, and 2 I am writing along with them, and cos alpha is coming as it is, 2 I am multiplying in cos alpha, and integration of dx will become here x. So this is my answer of the given question. Student, today we have finished till question number 13. Some of the questions are left in between the question number 1 to 13. Please finish today itself because gradually we are completing the syllabus and it cannot be covered afterwards. Okay, so it is better every day you form the habit. Some questions whichever I am explaining to you every day, you solve it and let me know your difficulties regularly. I will try to solve each and every difficulty from your side. Right? Thank you.